Hello everyone, and welcome back to my YouTube channel. Today we are discussing the solution of internal test 2. Here we have a question paper of that test and we are going to attempt the solution of the question one by one. We are starting with question number 1, which is what are the stages of text mining? Consider the examples of the complaint. The solution, the problem is theft of my mobile phone by an unknown person at MG Road on 2023-02-20. The phone was stolen when I was shopping at a store. The thief was wearing a black jacket and had a scar on his face, just like me. Suggest the approach algorithm process to identify applicable IPC BNS section to recommend applicable BNS section of IPC Indian Penal Code. Solution of that question. Stages of text mining. First, text preprocessing. Convert the text into a standard format by removing special characters, numbers, and stop words. Tokenize the text into meaningful units like words or phrases. For the given complaint, preprocessing includes converting text to lowercase, removing unnecessary elements like the date 2023-02-20 while retaining context. Second, text representation. Convert the clean text into a structured format using techniques like bag of words, TF-IDF, term frequency, inverse document frequency, or word embeddings like word to WAEC. Example representation of key terms, words like mobile, theft, MG road, unknown, thief, etc. are the key terms used in the complaint. Third, feature extraction. Extract features that help in classification such as named entities, locations, dates, objects, sentiments, or syntactic dependencies. Sorry, for this complaint, named entity recognition (NER) can identify MG road as a location and mobile phone as an object. Classification clustering use machine learning models, example naive-Bayes, SVM, or deep learning approaches like transformers or rule-based system to classify the text into predefined categories. Apply this to match the text with relevant IPC section, such as section 379 for theft. Fifth, mapping to legal codes. Link extracted features with BNS or IPC sections using a rule-based ontology or trained model. For example, theft is associated with IPC section 379 and road is associated with location of the crime. Now, the sixth step is the important one, which is the result interpretation, which means present the identified IPC or BNS sections with explanation for their relevance, how they are relevant to the case. Approach algorithm to identify IPC sections. Use a combination of a text preprocessing, named entity recognition, and rule-based mapping algorithm which are going to be used. Step 1, pre-process text, cleaning and tokenization. Step 2, perform NER to extract entities like location and objects. Step 3, match keywords, example theft, unknown person with IPC section mappings. Step 4, which is use a trained text classification model to improve accuracy of your solution. Step 5, which is to provide recommendations for IPC BNS section. Now we are moving to the question number 2, which is an important one. If you are interested in coding, it is going to be easy job for you, which is to give algorithm or Python snippet at a suitable place for the following tasks. A. Data preprocessing. The algorithm will be to remove punctuation, special key characters and numbers. Then to tokenize text, and then the third step we are going to remove the stop words and lematize. Python code snippets. Look at your screen and you will see that this is the Python code which I am going to run for the process of data preprocessing. First, we will import NLTK. Then from nltk.corpus import stop words. From nltk.tokenize import word tokenize. From nltk.stem import word net lemmatizer import string. Then for getting sample text, text is equal to theft of my mobile phone by unknown person at MG Road on 2023-020. Then we are going to pre-process the data, which we are going to write it as def pre-process text nltk dot download stop words nltk dot download tk nltk dot download wordnet stop words equal set stop words dot words English lemmatizers which are equal to wordnet lemmatizers. Now we are going to convert it to lowercase and remove punctuation, which we are going to do it by the text is equal to text dot lower. By using the lower function, we are going to convert it into the lowercase. Then in the next step, text is equal to text dot translate string dot make trans. We are removing the punctuation in this step, and after that tokenize and remove stop words. Words equal words tokenized text. Word equals lemmatizes dot lemmatize word for words in words if word not in stop words. We are removing the stop words from the text. Then we will return the joined words. Then we will print the preprocessed text here only. And in the next step, we are going to do classification. In the algorithm for the classification is going to be to first use supervised learning. Example, logistic regression, SVM with label data. The Python code snippet for the classification process is this one. From sklearn.feature extraction, we are extracting the feature. Then we are going to text import TFID vectorizer from sklearn.model selection import train test split. From sklearn.spm import linear SPC. Example data text is equal to theft of mobile phone, assault in public place, labels is equal to 1, 2, where 1 equals theft and 2 is equal to assault. These are the two cases that has been found. First is the theft and the second is the assault that has happened to that person. Now we are going to move to the vectorization process. Vectorizers, which is TFID vectorizers. X is equal to vectorizer dot fit transform text. And then to the train test split x train x text y train y test equals train test split x labels. Test size will be equal to 0.2. Just keep it there only. Train models. Model equal linear SVC. We are going to use this function. And after that, model dot fit x train and y train. Now to predict the outcomes, we are going to use these functions, which is sample equal to theft reported at MG Road. Sample vectorizer, we are going to using the vectorizer function to transform the sample data, which is the theft reporting at MG Road. We are going to print the model.predict, which we have predicted from this function. We are going to print it as a sample vector. Now, this third step, we are going to do the clustering. The algorithm for clustering is to apply super or unsupervised learning. Example, k-means. By using k-means, we can use the clustering, and we have learned about clustering in the previous classes. Especially the k-means we have learned. Python code snippet for the clustering process. From sklearn.feature extraction text import TFID vectorizers. From sklearn.cluster import k-means. Example of data. Text is equal to text of mobile phone assault in public place. Robbery of store. Vectorization. Vectorizer equals TFID vectorizer. X is equal to vectorizer dot fit transform texts. K means clustering. K means and clusters equals to random state 42. K means dot fit X. Print K means dot labels. Now the D section, which is true of decision tree, the Python code snippet for the decision tree will be from sklearn.tree import decision tree classifier. From sklearn.datasets import make classification. Now to generate data, xy equals make classification, n samples 100 and n features equal 4. Random state will be equal to 42. Train decision tree, model equals decision tree classifier, which is the function. Model fit x and y. Now to predict, print model dot predict 0.5, 0.5, and 0.5 and 0.5 are the predictions we are going to do. Now we are going to the E section, which is the last of this part of question, which is association rule modeling mining. Association rule mining. We had also talked about it in the last section of that course. The Python code snippet for this is from mlx10.frequent patterns import a priori. And then association rules import pandas as PD. We are importing pandas as PD. Sample data. Data equals the sample data that we have equals mobile 101 and assault 011 and the robbery 001. DF equals PD dot data frame data. Frequent item sets. Frequent item sets equals a priori DF minimum support 0.5. Use call names true. Association rules. Association rules frequent item sets metric lift mean threshold equals 1, which is print rules. Now to question number 3, which is going to be the last question of this question paper. Given algorithm R Python code snippet over a linear classification model, least square principle for fitting the best fit linear curve in a scatter plot. Answer for the question is algorithm. Plot scattered data points. Compute the linear regression line using least squares. Python code snippet for it. Import numpy as np. Import matplotlib.myplot as plt. Data points which are going to be x equal to np.array 1, 2, 3, 4, 5, y equals np.array 2, 4, 5, 4, 5. Linear regression using least square. Coefficient equals np.polyfit xy1. Degree equals 1 for linear fit line. np.poly1d coefficients. Then we are going to plot the solutions. plt dot scatter, which is going to be xy color blue label equals data points. plt dot plot x line x color is equal to label. Label equals to best fit line. plt dot legend. Legend function, we are using the legend function. And then last we are going to use plt dot show to show it on the screen that what is the solution of that algorithm that we has used, the model that which he has used. So we have come to the end of the solution part. We have done all the 3 questions of the question paper which we had. We had already discussed the internal test 1 solution. And next, in the upcoming days, I'm going to upload the solution of internal test 3rd and the end semester also. So for the solution, keep following my channel and like and subscribe. If you will subscribe, then you will get the notification of the new updates, the new videos which I will upload. So we are moving to the end of this video.